I'm not actually going to take a full minute to talk about it. It's very simple. You have items that occur, data points that occur, and some of those items may occur more than once. If they occur more than once, they occur with a certain frequency. Even if they occur once, the frequency would be one. But the frequency represents the amount of time something happens. Right? So think about it in a case where when we were talking about the mode, or we would say, well, if you could have more than one mode, or you could have many repeated situations. The most common number out of all of the data points would be your actual mode. But it is possible to have many repeating values among the data sets. Right? If that's the case, then many of these values are occurring frequently. Right? So the frequentliness of a number is known as the frequency. Right? So in this case, I mean, just kind of skipping ahead, you could pretty quickly and easily, I think, identify what the mode would be, because all you have to do is figure out what number occurs the most. And when you're talking about a frequency table, you're saying to yourself, 1 occurs 10 times, 2 occurs 3 times, 3 occurs once, 4 occurs 8 times, 5 occurs 5 times. Right? So when you read it out to yourself like that, it becomes painfully obvious what the mode is. But we'll get to that in a few minutes. Before we do that, we'll talk about the mean. We'll do it by hand, just the once. We'll do everything by hand just once. I'm not even going to assess you on doing it by hand. Right, so it won't be on a test or anything like that. I want you to get a sense of how these things work, and then you can be judicious down the line. You can make a decision. Well, I like doing it by hand for these particular situations. I like doing it by hand for these particular situations, or on the calculator for these particular situations. Right, so this is how you do it. You have a lovely formula, which most people, if you're not a math person, you look at that and you say, forget this course. I'm dropping today. But then when you think about it, order of operations works inside out. So start within the parentheses. It's telling you to multiply the x values by the f values. I created a column for that. So 1 times 10 is 10. 2 times 3 is 6. 3 times 1 is 3. 32. 25. Remember this funky symbol here, sigma, capital sigma. Sum. It's telling us to add those values up. So 16, 19, 51, 76. All right, so the numerator in my x bar, remember x bar is a symbol for mean. All right, that stands for sample mean. Okay. We are living in the world of sample means for this unit, so everything's a sample mean, so you could just think mean. You don't have to think sample mean. Once I introduce population mean, then you'll have to distinguish between the two. So the numerator is 76, assuming I did that right. The denominator is the sum of all of our f values. 14, 22, 27. So we'll get an approximate here. Oh, that's not a calculator. That's the calculator. That's not a knife. That's a knife. Movie reference? Too early for those? It's very old. Crocodile Dundee. Old movie. All right, so this is what the decimal reported, or the calculator reported in decimal form. Typically, we go 3 significant digits in this course, but I haven't really introduced that yet, so we just go whatever makes sense. If you're left your own devices in rounding, that's fine. Once you decide how you're going to round, cool, just make sure you do it right. because people they would argue for a point on a test and say, all right, I decided I was going to round to 3 digits, and they see like a -1/2 next to their score, next to their work. So why did I lose half the point? Say, yeah, I appreciate that you rounded to 3 digits, but you didn't do it right. So if you're going to round this, it's going to be 2.815. That 4 is going to go up. What is it? 5 or above? Give it a shove. That's what the line. I remember because I never learned that when I was in school, but when I became a teacher, some things became necessary because you try to explain things with the standard methodology, and you try it 3 different ways, and after the 3rd way, you're like, okay, you get it after that one, right? And you're still looking at a class of people that are like, I have no idea what the hell you're talking about. I'm like, okay, crap. All right, now we got to reach here. But my niece was learning rounding. Yeah, this is when Common Core was first coming out. So they had to draw like these pictures that involve ladders, I think. I figured it out eventually, but it's the kind of thing like Common Core is broken when the adult first has to figure it out in order to then explain it to the kid. Like, it should be something more intuitive, right? Like the old way wasn't working, so let's do this new way because this new way is like easy to understand and accessible to everyone. That's what it should be, but that's not what it is. So that's why everybody switched to iPhones, when they first came out, because iPhones made more sense than what was on the market at that time, the BlackBerry. It was more intuitive, right? That's what I think. But anyway, so the teacher teaching this lesson had their Common Core approved lesson plan with the ladders and all that stuff and all the instructions. And right at the bottom, in like fine print, it said, if it's 5 or above, give it a shove. If it's 4 or below, let it go. And it's like, here, I'm doing this because he told me to do it, but just do it this way because you'll get stuff right and it'll make more sense. So that's the way to go. Right? So decide where it's going to be. Most people don't have issues with the 5 or above business. They have issues with where the tenths, hundredths, and thousands place are. So if this seems like a complete and total waste of your time, that's fine. Go to the bathroom or something, I guess. But I'm going to take a second just because on the first test, half the class traditionally has lost credit somewhere for rounding. And if I can do something to help against that, then maybe that'll be a good thing. So I'm going to put a number here, like, oh, well, maybe I'll take that number. I'll just go out there. So to the left of the decimal point, most people don't have trouble, but I'll put a few more digits there, like 3 and 1. Hundreds. Tens. Ones place. So this is kind of, I don't know if the word is embarrassing, but it's not my finest moment. So I learned yesterday why we call it hundreds, tens, and ones places, specifically the ones place. I just assumed because you were counting by ones, then counting by tens, then counting by 100s. And that was a good enough definition that I never questioned it. But apparently it has to do with powers of 10. What? It's so crazy. So the ones place, 10 to the 0th power. The tens place, 10 to the 1st. And the hundreds place, 10 to the 2nd, and then so on. right? The reason why I learned about this is because I was teaching myself how to change to different bases, like a base 8 system and things like that. It just never came up in my courses of study, right? So this actually will work out really well because it's a good working definition. And so this guy over here is the 10th place. All right, so it's not the 1st place, it's the 10th place. This is the 100th place. And so on. Then we have the thousandths. And then the 10,000ths. It's not in my wheelhouse in fiction. All right, so let's just address maybe the tenths and the hundredths. Because I always just remembered that it was just offset by 1, right? There's no ones place for the decimal side. It just starts 1 over for there for some reason. Right? But let me show you why. This is the first time, 18 years of teaching this course, this is the first time I'm going over this, so I'm hoping that it's actually going to help people not use this anymore. We'll see. I'm going to collect data on it. That's what I did. So we had hundreds, tens, ones as we worked from left to right. Power of 2, 1, 0. If I'm decreasing in power by 1 every step of the way, the next one naturally would be 10 to the negative first. And then 10 to the negative second. The 10 to the negative first is equal to 0.1, which is 1 decimal place. The 10 to the negative second is 0.01, which is 2 decimal places. So then the next one would have 3 decimal places or 4 decimal places. Okay. So in terms of actually knowing the name and corresponding that to the actual decimal place, the 10th place gets its name from the fact that it is 1/10. 10 to the negative first is 1/10. Right, so it's the 10th place. 1/100th is equivalent to 10 to the negative second. So that's your 100th place. So it's getting its name from the fraction. Right? So if when you see the question, this is round to the nearest thousand, think to yourself there's 1 in 1,000, what does that correspond to? That corresponds to 0.001 in decimal form, which has 3 decimal units. Now you know how many units to round to. Carrying out the 5 or above, give it a shove business after that is that's your part of the job, but hopefully this at least gets you somewhere near the right answer. That's the idea. It was page 4.